Hello everyone, my name is Brandon Griffin, and today let's talk about how to do a mediation analysis, and specifically we're going to talk about calculating the Sobel test in Excel. Let's do this. When conducting a mediation analysis, you typically start with assessing the relationship between the independent variable and the dependent variable. In this example, let's assume based off the literature, we estimated that employee well-being is going to lead to an increase in job performance. So that's based off the literature, that's based off something that we hypothesized. But mediation attempts to answer the question of why or how does X impact Y. So we can presume that employee well-being is going to have a positive effect on job performance, but is there some third or intervening variable that actually is the cause of that relationship? Now, in mediation, we have a couple different things that we need to look at. We have the relationship between our independent variable, our X variable, and in this case, employee well-being, to the mediating variable. And in this example, it's got job engagement. And this is called the A path. And then we have the relationship from the mediating variable to the dependent variable, job engagement to job performance, and this is called the B path. And additionally, we have the relationship between our X and Y variable while also testing for this mediating variable, and that is called our C prime path. So let's assume for a minute that we predict employee well-being will lead to an increase in job performance, but based on their literature, we think that employee well-being is actually going to increase job engagement, and it is job engagement that will lead to the job performance. So we predict that there is going to be mediation that exists. Now, the direct effect refers to the relationship of the A and B path, so the mediation. So that's the A path and the B path. And the direct effect refers to the C prime path. So that's the relationship of X and Y while also taking into account the mediated path. So if we want to figure out if we have mediation, if we have a case for mediation, we need to calculate some type of statistic, and this is why we're doing the Sobel test. A couple of resources I used in preparing my tool and this lecture are quantsci.org, McKinnon et al. 2002, Barron and Kenny 1986, and then also David A. Kenny's website, davidakenney.net. And today, when conducting mediation and moderation analyses, people typically prefer bootstrapping or structural equation modeling approaches. But because of Barron and Kenny's 1986 model, the Sobel test and variants of the Sobel test remain very popular in assessing mediation. However, there are some assumptions with the Sobel test that give it weaknesses and that give it inherent limitations, and that's why people rely on bootstrapping and structural equation modeling rather than simply relying on the Sobel test. However, it's still valuable to learn because a lot of people, when learning mediation for the first time, they will go over the 4-step causal steps approach from this Barron and Kenny 1986 article. And it looks like I spelled that wrong. And let's go through that, how to calculate the Sobel test and actually how to get answers with our calculator. So first off, what is the Sobel test? It's to test whether a mediator carries the influence of an IV to a DV. And this comes from quantsci.org. So you're literally examining if the mediator is the cause of the influence between the IV and the DV. And mediation, again, answers the question of why or how does the X impact Y. And we need to do a couple different things to get our Sobel result. So first off, we need to run a regression to assess the relationship between our X variable and our mediating variable. And this will give us our unstandardized beta coefficient and our standard error for our A path. And then in addition, we need to get our B path. And this doesn't mean simply running a regression with our mediating variable going to our dependent variable. We have to include the mediator and the independent variable as predictors. So first off, we run a regression with X going to our mediator, and then our second regression is X and M going to our dependent variable. And then based on our unstandardized beta coefficients, we can put it in our calculator and we will get the results. When I was preparing this lecture, I found a great tool by Ruben Geert Vandenberg at this spsstutorials.com, and my calculator is based heavily on his, but mine builds on it by, I changed some of the descriptions here, and I'm also building in references to the regressions that you'll conduct in Excel. But credit to Ruben Geert Vandenberg for this amazing tool that I'm adapting. So if we want to calculate the Sobel statistic, we need to look at the formula for this. So the Sobel test is the result that we're getting is essentially a z-value, and it is the combination of a couple different things. The numerator is our a path multiplied by our b path, so that is our x to mediating relationship and our mediating to y relationship, while also testing for x. And then we divide it by the square root of all of these terms, and essentially it is a combination between the unstandardized beta coefficients and the standard errors. So the z-value for the Sobel statistic is our a path coefficient multiplied by our b path coefficient divided by the square root of our b path squared multiplied by the standard error of a squared plus the a path squared multiplied by the standard error of b squared. Now, if you look in the Barron and Kenny 1986 article, he uses a slightly different version, and there are really three main types of the Sobel test that people use, but this kind of goes back to the original Sobel test. All of them are going to be similar, but some of them have their differences that are minute in detail, but are important depending on your research scenario. So dig into those papers a little bit more. That McKinnon 2002 article does a really great job of breaking that down. And I have instructions of how to actually use this Sobel test and then all of my references here. So to work with this calculator, we need to do two separate regressions. And the way I have it built, if you do your regressions where I tell you to put them, it'll automatically pull the values and it will calculate your Sobel test directly. Or you can input them in blue and it'll calculate them in green. So let's look at our data. First, we have the relationship between our independent variable to our mediator. So we have X well-being, we have the mediating of engagement, and then we have our Y value of performance, which we will not use for this first regression. So let me go ahead and clear out all of these results right here. To run a regression in Excel, you need to have the Data Analysis Toolpack add-in selected. To do this, you need to go File, Options, Add-ins, and then you need to add this Analysis Toolpack. So you can hit Go, make sure you select the Analysis Toolpack, hit OK, and it should show up under this Data tab. Now on my calculator, under the instructions, I say that if you put your regression output in the E1 position, it will auto-calculate into the calculator itself. So what we're going to do here, we're doing step one, where we regress the mediator onto the independent variable. So the independent variable is our predictor, and our mediator is actually our dependent variable in this analysis. So let's go to Data, Data Analysis, let that load. And we need to scroll down to regression, hit OK, and our Y range is going to be our mediating variable. So our dependent variable in this case is our mediator. And yes, we have labels, and our X range is going to be our X variable. Yes, we have labels. So here for my Y range, I'm doing B1 to B21. My X range is A1 to A21. I have labels. And make sure you put the output as that E1. So hit output range, select E1, and hit OK. Let's go ahead and widen these columns so we can see. And so when we look, our X variable, our predictor of well-being, shows a unstandardized beta coefficient of 0.567 with a standard error of 0.165 and also a p-value of 0.003. So we can see that our independent variable has a statistically significant relationship with our mediating variable. So next, we need to determine the impact that our independent variable and our mediating variable have on the dependent variable together. So let's come over here. Let me delete these cells that I was working with previously. And we need to go to Data, Data Analysis, and it's automatically going to have all the settings that we previously used. So our Y range we need to change. Previously, we treated the mediating variable as our dependent Y variable. So our new Y range is going to be C1 through C21, and our X range is going to be our two predictors, in this case our X variable and our mediating variable. But in Excel, when you're running a multiple regression like this with multiple predictors, you need to make sure that those predictors are in columns next to each other. So I'm using columns A, column B. So my X range is A1 through B21. Yes, it has labels, and put the output range as E1, and then hit OK. And then it puts out this summary statistic here. So we can see our engagement, which is what we're looking for, has a coefficient of 0.611, a standard error of 0.22, and a p-value of 0.01. And then also our well-being is a 0.55. So we can come over to our calculator and let's double check our results. So our our A path and our standard error of A are 0.567, 0.165. So this is 0.567, 0.165. All right, and then our B path and our standard error of B is 612 and 227. 612, 227. All right, that is looking pretty good. And it does include all the data, but I rounded it to 3 decimal places. And this is where the information from Ruben Geert Vanderberg really came in handy. So I had the p-value, I had the Sobel test, I had the standard error and the indirect effect, but I was able to make it look a little bit cleaner and a little bit neater after looking at his calculator. So to calculate our z-score, or our z-value, from the Sobel test, we need to calculate the indirect effect. So that is A multiplied by B, which is calculated here in row 8. Next, we need to calculate our standard error indirect effect. And this is going to be the square root of our B squared multiplied by the standard error of A squared, plus A squared multiplied by the standard error of B squared. And we have it all fit in here. And this is where the Sobel equations are going to differ. Some have extra terms at the end in your denominator, but I'm just using the standard Sobel test. And then we are given our Sobel statistic, which is simply dividing the numerator, our indirect effect, by that standard error, which gives us 2.12. And then based on a uniform normal distribution, we get a p-value of 0.034, which is less than 0.05. So we can assume that we have mediation according to our example because the p-value is less than 0.05. So the null hypothesis for the example is saying that the direct effect is not significantly different from 0. But because we have a p-value of less than 0.05, we can assume, or at least have some support, that our indirect effect is statistically significant from 0. And then we also have our lower bound 95% confidence interval and our upper bound 95% confidence interval. And remember, if 0 is included in that confidence interval, you do not have statistical significance. And because our p-value is less than 0.05 and our 95% confidence interval does not include 0, it means that we have statistical significance at the 95% or the 0.05 alpha level. So in this case, we can say that employee well-being mediates the relationship, we can say that job engagement mediates the relationship between employee well-being and job performance. Now, it's important to know that there are 2 separate types of mediation. There's full mediation and there's partial mediation. If we go back to Barron and Kenny's 1986 model, the 4 steps to running a mediation model are assessing the relationship between X and Y, and then doing your mediation. And if after including your mediating variable, if the relationship between X and Y is no longer statistically significant, you can assume that you have full mediation. But if that relationship is just reduced, you have partial mediation, because there's still an impact between X and Y. But in our case, we are just simply looking at mediation. So if we wanted to calculate that, we could, and let's actually go ahead and do that right now. So I'm going to copy and paste all of my data that I have here, and I'm going to create a new sheet. I should have done this beforehand, but this is what we're doing now. And this one is simply going to be the relationship between our independent variable to our mediating variable. I'll go ahead and zoom in a little bit here so you can see. And I think I misspoke. So this is going to be the relationship between our independent variable to our dependent variable right here, and I'll put that in E1. So let's run a regression. So let's go to data, let's go to data analysis, go to regression. Our input Y range is going to be C1 through C21. Yes, that's correct, but our X range is going to be the A column, A1 through A21. We have labels. Our output range is E1, and let's hit OK. So we can see based on our output that well-being is a statistically significant predictor of job performance. Has a p-value of 0.02. And we can see Based on our second equation, when we include our independent variable, we can see that this p-value is no longer statistically significant, meaning that according to this model, we can assume that there is full mediation, or that when we include the mediating variable, the relationship between our independent variable and our dependent variable is no longer statistically significant. So I added this little bottom section to make it clear that we can assess full or partial mediation in this calculator. So when running a simple regression of the independent variable to the dependent variable, we look at the p-value, and here it's a p-value of 0.02. But when we include the mediating variable, if the relationship is no longer statistically significant between the independent variable and the dependent variable, we have full mediation. Whereas if the relationship was reduced, say it goes from 0.02 to 0.04, we have partial mediation. But in this case, because it is no longer statistically significant, meaning that it's greater than 0.05, we can assume that job engagement fully mediates the relationship between employee well-being and job performance. Thank you so much for watching this video. Good luck in calculating the Sobel test. Let me know if you have any questions, comments, or concerns, and as always, have a great day and happy learning.